Okay, last video, so just doing a couple of examples. So we're trying to sketch x take 1, x take 3, x plus 5. Okay, like before, okay, x take 1, well it's going to be the opposite, so it's going to be positive 1 as our first x-intercept. X take 3, again, it's going to be a 3 here, and 5 is going to be negative. So first part, when we have x-intercept form, something that looks like this, really easy because we just put in our x-intercepts. Okay, if we expanded that out, we'd have a value of greater than 0 because there's no constant in front of the x's. X times x times x gives us x cubed. Now, that indicates that the graph will start below the axes, x-axis, so just connecting the dots again. Looks something like that. Now to find the y-intercept, we do want to find that, so x take 1, x take 3, and x plus 5. Okay, sorry, that was for x-intercepts. Okay, solving for 0, x take 1 equals 0, x is 1. X take 3 equals 0 is 3, x plus 5 is minus 5, so that's where they come from. Now y-intercept is the opposite, so y is just sub 0 for every x, so 0 take 1, 0 take 3, 0 plus 5. So we'll have minus 1 times minus 3 times positive 5, minus 1 times minus 3, positive 3 times 5, so it's 15. So put that in as 15, and that's all we need to do for the moment. Now we could find the turning points, we'll do that later on. So that's for the first example. This one, similar. So again, let's write it down, x-intercept. So 0 is x plus 1, 2x take 5, and 6 take x. So our first one is going to be, okay, x plus 1 is, x is minus 1. Our next one, 2x plus 5, sorry, 2x take 5 is 0. So plus 5 divided by 2. And our last one, 6 take x equals 0. So x is going to be 6. So there are 3 points. So we've got positive 6 here. 5 on 2, well, it's about here, and minus 1. Again, multiply this out, x times x times x will give us x cubed. Now, constant terms, 2 times minus 1 gives us minus 2, and that's less than 0, so it's going to start above the x-axis. So that's cubic graphs.